Good afternoon, students. Today we discuss about the coordinate system. So basic terminologies we go through it. So the basic terminology is, so what is mean by a coordinate, and important formula we will discuss it today in this session. So let us begin this. So coordinate system. Coordinate system. So basically it is coordinate of any point on the x-axis is of the form a comma 0. That is, the point on x-axis means, so y coordinate we have to take it as 0. So any one scalar quantity a will be the x coordinate. Similarly, the point on a y axis is taken as a 0. That only it is given. Similarly, coordinate of any point on the y-axis is, we have to take x coordinate as a 0, y coordinate is any point, we represent it as a. Then we have a 2 points P and Q. The coordinate of P is x1 y1, coordinate of Q is x2 y2. Then the length between the points P and Q is given by the expression under the square root of x2 minus x1 whole square plus y2 minus y1 whole square. Similarly, the distance of a point x1 y1 and from the origin, the point Q is origin, then here you can substitute like x2 is 0, y2 is 0, then we get this expression root of x1 square plus y1 square. Next, section formula. See, suppose that we have coordinates x1 and y1, point P it is having a coordinate x1 y1, point Q x2 y2 is a coordinate. If they cut internally in the ratio L and M, that is, the length L will be the distance between P and one point, and another that point and Q is M. So L is to M. Then the section formula is given by this expression. So L into x2 plus M into x1 divided by L plus M. Similarly, so x is replaced by a y. So here we get a y2 y1 divided by L plus M. You have to make it as a correction y1 here. So this is a formula of a section formula. Already you have studied, just it is a revision. Next, the coordinates of the point which divides the join of a point P x1 y1 and point Q x2 y2 externally means, so the previous formula only, this previous formula we have a plus here, so we have to change a sign, so it will become a minus here, here also minus. So x coordinate we have to change it by y, so here also we have to take it as a minus here. So this is a cut externally the formula. Next, midpoint formula. Midpoint formula means we have to take the formula of this cut internally. In this we have to substitute L equal to 1 and M equal to, we have to take it as a 1. So then simplifying we get this as x1 plus x2 divided by 2, then y1 plus y2 divided by 2. Next, coordinates of the centroid of a triangle whose vertices are point A x1 y1, point B x2 y2, point C x3 y3 is given by centroid of a formula. See, just all three x coordinate we have to take it x1 plus x2 plus x3, we have to divide it by 3. Similarly, y1 plus y2 plus y3 whole divided by 3 we have to take it. Next, slope of the line joining the point P of x1 y1 and Q of x2 y2 is given by the formula using the coordinate system. So using a process of a differentiation we can find a slope. So that is it is called as a first order differentiation. So slope is dy by dx, or else slope is tan theta. So if you use a coordinate system, then slope of this P and Q is given by y2 minus y1 divided by x2 minus x1. This is a formula. If two lines are parallel, then their slopes are equal and conversely. Then if the lines are perpendicular, then the product of their slopes is -1. conversely, that is, if like lines are parallel, then m1 is a first slope, m2 is a second slope, m1 equal to m2, we get it. That is a point. Then if two lines, they are perpendicular, then we have to take a multiplication of those. So m1 is a first slope, m2 is a second slope, and then we get m1 into m2, m1 into m2 equal to -1. That is perpendicular condition. Once again I am repeating, parallel condition is m1 equal to m2, and perpendicular condition is m1 is multiplied by m2 equal to -1. Next, standard forms of equations of a line. Equations of a coordinate axis and line parallel to coordinate axis. Equation of a x-axis is y equal to 0. Here already I told you, the point on a x-axis means the opposite coordinate we have to take it as a 0, and if any line parallel to x-axis is of the form y equal to a, where a is called as a constant. Similarly, on the other hand, so now we have discussed about a x-axis. Similarly, now we will discuss about a y-axis. Equation of a y-axis is x equal to 0, and that of any line parallel to y-axis is of the form x equal to a, where a is a constant. Similarly, equation of a line through a comma b and parallel to x-axis is y equal to b. Similarly, equation of a line passing through a comma b parallel to y-axis is x equal to a. So very important while solving the example. So we are using these coordinate system and parallel to one axis, what is the condition for another one. So very important it is. Okay. Similarly, slope point form means see, the equation of a line passing through one point is given here, that is x1 y1, and slope is given. Then the related formula is y minus y1 equal to m times x minus x1. Y minus y1 equal to m times x minus x1. This is a slope point formula. Then excuse me, 2-point formula. Suppose that the equation of a line passing through 2 points. First point is x1 y1, second point is x2 y2. Then its related formula is y minus y1 divided by x minus x1. Just so here it is y2 minus y1 divided by x2 minus x1. This is a formula. Next, slope intercept form. Slope intercept form means y equal to mx plus c. It is called as a slope intercept form. So here y is a coordinate, x is x coordinate, m is a slope, and plus c, it is a intercept. That is on a particular graph there is a length is a present. So it is a c is called as a intercept. Next, intercept form. Intercept form is like x intercept we have a, y intercept we have a b, and intercept form is x by a plus y by b equal to 1. Very simple it is. Then normal form. Normal form of a equation, x into cos alpha. Alpha, it is an angle, plus y into sin alpha equal to p. Here p is a length of the perpendicular from the origin, and alpha is an angle made by this perpendicular with the x-axis in the positive direction. Then the equation of a line is given by that particular formula. Okay. Next, parametric form. So first we need to understand what is mean by a parametric form. Suppose that like y and x are two variables. Suppose that if it is a x, it is a represented in terms of a theta. You can see here x is represented in terms of a theta, y is represented in terms of a theta. So this is theta is a third variable. So then x, it is in terms of a y, it must be. So y in terms of a x, it must be. So now x and y define up to a theta. So such type of equations we call it as a parametric form. Already we have discussed in a differentiation. So x is a function of a theta, y is a function of a theta. So separately we have to find a differentiation, dx upon d theta and dy upon d theta, and on simplification we get dy by dx. So that is a parametric form here. Okay, so here the equation is parametric form, x equal to x1 plus r cos theta. One more is y equal to y1 plus r sin theta. This is the equation. Theta, it is the angle of inclination of the lines. So next we'll discuss general equation of a line. Already you have studied, so some of the things are new. Just everyone go through it. The general linear equation is ax plus by plus c equal to 0. Always it represent a straight line, because I told you, see, many times, see, you can see the variable here, constant and variable, a raised to 1, x raised to 1, b raised to 1, y raised to 1, c raised to 1. Therefore all are linear, therefore this is a straight line. So similarly, slope of this particular line is given by the formula minus a by b. Very important it is. And x intercept is minus c by a, and y intercept is minus c by b. Once again, so slope is minus a by b, x coordinate minus of x coordinate divided by y coordinate. X intercept is minus c by a, it is minus c by x coordinate. It is a multiple. Okay, so y intercept is minus c divided by y, it is a multiple. So like that it is a defined. So suppose that we have two lines, a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. Then if we take the x coordinate ratio, y coordinate ratio, and constant ratio, that is a1 by a2, b1 by b2, c1 by c2, here it is defined. If it is the same, then then it is called as a coincident line. Coincident line it is called. Okay, so like that in a 10th standard you have studied like intersecting, coincident, infinitely many solution, no solution. So it comes in that category. Okay, next, so some of important points here. So instead of solving a lengthy example, here is a direct formula. Using this direct formula we can solve the many examples, dear students. Just to focus it. So very important to note it is. So first there is a note it is, and so using that one example there is a verification here, how we have to take it and how it works here. So suppose that we have a point x1 y1 and x2 y2 are the end points of the hypotenuse of a right angled isosceles triangle. Then the third vertex is given by, see here, they have given us the two coordinates x1 y1, another coordinate is x2 y2. Then end of the hypotenuse is right angled isosceles triangle. Then third vertex is x1 plus x2 plus or minus y1 minus y2 divided by 2. One more is here it is a x coordinate, so I replace it by y coordinate, y1 plus y2. Here it is plus or minus, minus or plus, so y coordinate is replaced by x1 minus x2. Here also divided by 2, divided by 2. Like that, if you remember one coordinate, so this is the first coordinate. Second coordinate is very easy to remember. X we have to replace it by y by x, and a plus or minus here it is minus or plus, whole divided by 2 both side. Suppose that here is a one example x1 y1 it is having a coordinate 7, 9, x2 y2 it is so 3, minus 7. Then ends of a hypotenuse of a right angled isosceles triangle, third vertex is given by, so 7 plus 3 plus or minus 9 minus 7 whole divided by 2. Similarly this one we have to substitute, and simplification, we get 13 minus 1 minus 3 plus 3. So like this it is. So we have to simplify. Yes. So next point, if two vertices of an equilateral triangle, so you know what is meant by equilateral. Equilateral triangle is all sides are of a equal length, all angles are exactly equal to 60 degree. Such a type of a triangle we call it as a equilateral triangle. Here the points are x1 y1 and x2 y2. Then the third vertex is given by x1 plus x2 plus or minus root 3 y1 minus y2 divided by 2 here. So x is replaced by y, so plus or minus, minus or plus, root 3 constant it will remain, y is replaced by x whole divided by 2 both sides, like this, very simple. So here there is a one example for a verification. X1 y1 is 3 comma 4 and x2 y2 is minus 2 comma 3. In this formula x1 is 3, x2 is minus 2, y1 is 4, y2 is plus 3. We have to substitute in the this above equation, then simplification, it leads to these two solutions here, these two solutions, like this we have to simplify it. So the last point, the ratio L is to M in which the points P of xy divides the line joining the points A of x1 y1 and B of x2 y2 is given by the formula. So it is L by M equal to x minus x1 divided by x2 minus x. So here very easy here. So or else one more formula we have, just x we have to replace it by y here, like this we are going to get it. So suppose that P is a point 2, 7 x and y, x1 y1 is 8 and 9 and x2 y2 is like this. So then we can find, substituting in the formula we can simplify the solution for a so given equation here. So here L and M is a ratio, and further what we'll observe is there is a point A having a coordinate x1 and y1, and another one is a point it is a x2 y2. So using this we have to simplify it. Okay, so today in this session we have discussed about the basic things. The basic things is what regarding we have studied coordinate system, important formula, and in the next session the same thing, the problems will solve it. So thank you for watching. Thank you very much once again.